Hello, thank you for joining us today. This is the webinar, Driving Climate Action, the En-ROADS Simulation Experience, presented by Republic EN. My name is Angela, and I'm Republic EN's Engagement Director. We are an organization building community for conservatives who care about climate change and want to take action. I'm going to turn the mic over to our Executive Director, former Congressman Bob Inglis.
Thank you, Angela. And thank you all for joining us. This is a pretty exciting opportunity to see some science and some modeling in action. And so we're going to be featuring here I think he's famous, Drew Jones, this guy who has well, let's see. I'll tell you a little bit about Drew. Okay, so he lives in Asheville, North Carolina, which is right up the hill from us here in South Carolina. Went to Dartmouth, then got another degree at MIT, teaches now at the MIT Sloan School of Business and also at the UNC School of Business. We won't hold that against him on this call. We're going to suspend that for a while. It's a faded out blue color there. You know, there's a deeper, darker, more robust blue right down the street.
No. Bob, I didn't realize.
Right down the street in Durham, North Carolina. But anyway, we won't hold that against him, as I say. You know, it might look like we at republicen.org are somehow connected to this thing called En-ROADS. You know, you notice the EN. We're not a wholly owned subsidiary, but we are in a mutual admiration society because I go around all the time. In fact, as recently as yesterday, was telling two groups, you want to see how things work? Well, go to En-ROADS and play around with the simulator. And so that's what I'm excited about you seeing here today is Drew did this. My first experience with Drew was actually at a conference, but then we did a simulation in Greenville, South Carolina years ago. And what was really great about that is you can play it as teams. And so, Drew, I'm messing up your deal because every audience that it comes up in, and it comes up most time when I'm speaking, I say, here's how to win. If you're ever in a competition, I go ahead and tell them how to win. But that's self-serving because that's the solution that we like so much. But anyhow, so we are very excited to have Drew Jones with us. And he's got the whole presentation. So my only role now is to say, welcome, Drew, and take it away and show us this fabulous model that you and your team have developed.
Great. All right. Well, thank you, Bob. And just appreciating your leadership from way back. I remember when there was this courageous congressman nearby in Greenville.
This premiere for you.
Boy, just your leadership then and the heat that you took and now what you've done in this next stage of your work is just an inspiration to me. So appreciating all that you've done and Republic EN as well.
Thanks.
And so here we are. What we're going to do is we're going to use a simulator to address this challenge in communications around climate and energy and all these issues. This problem that our collaborator at MIT, he said it best, that when it comes to all these issues, research shows that showing people research doesn't work. Research shows that showing people research just doesn't work. We, for a long time, have talked about together what would be necessary to drive the energy transition and other things, and it doesn't really land. What does land is people thinking for themselves on their own terms. That's what we're going to do today. That's what we've been doing. This is a picture in the House of Representatives of people, Congress people talking to each other grounded in the simulator that we're about to play with. So that's the setup that we really like. So you're going to be doing this yourself in just a minute with our simulator En-ROADS. And this is one that we also use just one-on-one. John Curtis, the head of the Conservative Climate Caucus, is one of the people that we've met with. I was out at the Aspen Institute. That picture here is the two of us before breakfast. He said, I want to play with this simulator a good bit. And then we met in Egypt at the last COP. Senator Mitt Romney as well, also was somebody we spent a lot of time with, mostly his staff, simulating different scenarios. And he talked about it as there's this professor at MIT who made this model that allows you to sit down to say, I'm going to make these changes. That's En-ROADS, the simulator that you're about to play with. And we've been sharing this with a lot of leaders, over 4,000 across government, business, and academia. But we come out of the think tank world, and we are a nonprofit think tank that works closely with people who helped build the model at MIT. So we're going to be looking at this simulator, and we have this time together really to just play. So I'm going to ask you to think, what would you want to test in it? And really the first thing to look at will be just grounding ourselves in what matters. So would you write in chat? We're going to use chat a good bit here. If you would share, what are the impacts around this climate challenge that matter to you, that concern you, that you'd want to see? And we can go and look at some of them. So if you would go into chat, I'm typing in here. I just wrote hello, and Bob says sea level rise, water availability, and many issues on water. Maybe Bill, which aspect of water comes to mind? Is it water use or precipitation, water for agriculture? Incremental impact of a second home. Can we calculate that? Public health, says Matt, all in water. Public health. Several people writing about public health. I'll maybe just start there. And in this baseline future that we'll talk a little bit more about, here we have, with public health, I think the main one to look at is what leads to 1 in 10 deaths on planet Earth today, which is air pollution. We measure it as PM 2.5 emissions. It's primarily from coal, but other sources. And we can measure it here in these megatons of PM 2.5 a year. It's been going up. And this is from 2000 to 2100. Here's the history of it. Up, up, up. Here we are today. There's the little COVID blip as it dropped, as we use a little less coal in the world. But it's expected to go up primarily because of more coal. And so we see this and we think, boy, can we bend this curve? So remember that shape, and then we're going to come back later to see, can we come up with actions that would bend that curve? I'll go and look at some others, and I'm going to look at your chat. I saw sea level rise. Maybe could someone, I'm going to add sea level rise here, maybe write into chat, what are some places in the world? This opened up to Alexandria, Egypt. But what is a place in the world where you'd want to look at what's coming with sea level rise? And of course, the idea here is the Earth warms. The main reason we have sea level rise is that warm water is bigger. Oceans warm. Oceans are just a little bit bigger, and that leads to sea level rise. We also have some land ice melted, Greenland, Antarctica. But people are writing Charleston, Hoboken, Charleston. So we go into here and type in Charleston. Well, I got to move some Charleston. Oh boy. So I haven't looked at Charleston in a while. One of my favorite places to go when I want to go see the ocean from here in Asheville. And okay, here, of course, is the Southeast, the US. I'm going to zoom in, and we can see some of these places. Is there an area of the person who wrote that they'd want to look at? here, Charleston, we see Dewey's Island, Sullivan's, Folly Beach, the place I've been, Kiowa, I've been there as well. Boy, a good bit of blue. Blue is land at risk. And later we can go and see if we prevent some warming, are there places that wouldn't be at risk? And really, it's interesting to look at some of these river deltas where up the river, we have a good bit of sea level rise, not just right on the ocean. So again, just building the need for action. And I'm looking to see what the other things, public health, drought and drying up of rivers and wildlife. Here in impacts, we can also go look with wildlife, biodiversity. So people who care about the land and animals, this is a measure of the species losing more than 50% of their climatic range due to the warming. Invertebrates, vertebrates, plants, insects, mammals, of which we are one. That line right there means that 2% of species have lost more than their range, 50% today. But it's anticipated by 2100 to be at 24%. And along the way, when you see something like that, it's like, wow, where did that come from? And you want to go check it out. And I'm going to send you the model in a minute. Go and click on this little triangle and you'll see, oh, here's the study. And you can then go pull up that study and go, if you like, digging into it, of where did that information come from? And here with these results, you see me clicking in the corner here on share your scenario. I'm going to copy this link and I'm going to put it right here into chat. And now you can go click on it and see those two maps yourself and do what, if you like multitasking, play with it yourself, see if you can improve biodiversity or sea level rise there with the model. And this is an important principle, the transparency. Here is the model. All of the equations are shared online for you to look at. Many of the assumptions are changeable. If you disagree with some of the assumptions, you can explore how it would be different if permafrost behaved differently or the temperature rose differently with atmospheric carbon. These are all available. And really, because this is a global challenge, the US has a decreasing share of the pollution that causes this problem. It's around 15%. And so we need to get these tools and this thinking to people in the rest of the world. And so there are 20 languages if you have people who want to look at it elsewhere. So let's just take it here. Public health, air quality, sea level rise, biodiversity. There are others that you can go look at, but there's the setup. We know we want to be doing more, and we have so many economic reasons to care about the energy transition that we spend a lot of money on energy. I'm going to go here to financial and the total annual cost of energy. Can we do better spending money there? We also are going to have economic impacts of climate change. Can we avoid some of the global GDP loss from the damages? And we're calculating right now, based on some assumptions that economists have made, trillions of dollars per year. Here we have what? $31 trillion per year in damages by 2040. How do we do better? Okay, that's enough of the setup of can we do better? I want to start first, before really just making this better. Are there things that we could start with where you are wary that there are lower leverage actions that you think, oh, wait, there's a question along the way. We're going to look at stuff. Libby's asking, can we show how we expose the references or the origin of the data? Yeah, maybe I did that pretty quickly. Let me just make sure, and you can go in there and check this out yourself. So the main place is help. And if you go here to model technical reference. So if you love equations, etc., here is everything. So the terrestrial biosphere cycle or carbon removal, all of the equations about how we model it are here. Every parameter is shared as a constant. Here are all the numbers in the model, so you can go check them out. The other place that you'll go look that I started to show is we picked out certain ones because you don't want to change several hundred variables. Let's just pick the most important ones are under simulation and assumptions. And they are under Earth system and economy. When I showed you the damages from climate change, that's here. What is the assumption about what we call the damage function, bioenergy, progress ratios for how much cost comes down for nuclear and renewables and fusion, all these different supplies, carbon removal of different types. They're all here. So that's where it is. Can anyone use the model themselves, says Amy? Yes. I just sent you the link. You should click on it. It's right there at 12 p.m. in the chat. Click on it, play away. It's been used by 720,000 people around the world in these 20 languages. It's an amazing tool. Why did we choose those? Can we explain the two graphs and why we chose to highlight those? Sure. Here's the basic idea. This version of like where you don't dig underneath the hood is set up really for, we thought of really a smart 8th grade kid to come to this, or it sits in the MIT museum, or it sits in Austria in a museum where you could come to it. And then in my mind, in our minds, follow the logic of this challenge from the biggest drivers of pollution, the pollution, and then the result from left to right. So what is the main source of global warming? Coal, oil, and gas, energy. So where is the energy? That's on the left. What is the overall pollution, including methane and nitrous oxide and the F gases, here in the kind of right side? And then over on the right, a simple measure. We could have chosen a lot of things like, let's get to net zero, but here it's a game. And the game would be, can you get that 3.3 or that 6? And of course, here in the US, we can do it as, can you get that 6 degrees F down to well below 3.6, which is the goal that the countries of the world sign on to get to, or even down to a better goal. And those goals you can go look at here. If we click on, and by the way, see this graph right here, this thumbnail right here, you can click on that and you see our favorite 12 graphs. Temperature is one of them. Can we get that 6 down here to 2.8 or 3.6 or down to 2.8? So the logic is, and then make it really simple where somebody could just start clicking things like renewable energy and carbon pricing and less coal and methane, etc. That's why we chose those graphs. That's the overall setup. You're really doing great with asking questions in here. This is great. And then Greg says, also click on the 3 dots. Yes, that's the advanced view where if you don't want to just use this basic of change the energy, change the pollution, see the temperature, then you can also dig in and see, well, wait, with carbon price, it's not just, well, high, low. Instead, you can go and set very specific numbers and years and phasing in, and then big decisions like, well, all sorts of other things. That's the basic setup. Okay, so my question to you, I'm going to come back here to what are some actions on climate that you hear of that you're a little bit wary aren't as powerful as they get discussed, say in the media or say in public discourse on this issue? What are some issues? And maybe just write in chat. I'm going to start there before we cut to the things. Bill Hurley says trees. Bill Hurley says trees. Bill Hurley, everyone keep writing, but I'm going to go straight there. I got to go straight there. Let's go look at trees. Let's go look at planting trees. Now note, there are many reasons to plant trees. If you've been around the world and seen what is needed to address erosion in cities, shading, overall biodiversity, to have forests and wildlife, community economic development project, we need more trees around the world. What we're assessing here is how much could planting trees pull carbon out of the atmosphere, at what time scale, in order to bring our emissions down to net zero and bend this curve of temperature. So the way we think about that is over here under afforestation, we can go plant trees. And I'm going to pull up removals. The way to think of this, of course, is we have emissions into the atmosphere, burning coal, oil, and gas, methane, deforestation, puts greenhouse gases in the atmosphere. We also have removals, possibilities around direct air capture, ag soil carbon retention, in this case, planting trees. So let's go try it under here. And I guess I'd like to think what I'm going to do is I'm going to plant a lot of trees. The most that some studies of this thing could possibly be done probably wouldn't happen. But if we were to plant, actually, I'll go all the way to 1 trillion. And to get 1 trillion trees, under assumptions, I'm going to go to afforestation settings. And it turns out we need 840 million hectares. It's about the size of the contiguous US. We're going to plant 1 trillion trees. And that temperature of 6, how much do you think it's going to come down? We want to get it to be all the way to 3.6. Would you write into chat, if we planted 1 trillion trees, what you think that temperature is going to be in 2100? Someone says, does it matter where the trees are geographically? Alex, in reality, yes. Trees grow faster closer to the equator generally, get more sun, it's warmer. And yet, think of this as distributed around the world in all the places where we might have marginal land, some reforestation, pretty aggregated. So we're going to have to think of it as the spread out around the world. So Alex says 0.5 degrees if we plant 1 trillion trees, says Alex. 0.5, so 6.0 F would go down to 5.5 is that guess. This is it. Play with me, people other than Alex. Think of yourselves as playing a bit of a game, like make a guess, but write it down here. Learning theory says you're more likely to learn if you actually commit to something. Bill says 0.1. Amy says all the way down to 3. So we have someone says 5.5. Someone says down to 3. Bill Hurley is saying 6.0 goes to 5.9. Great. We have a diversity of views. Here we go. We're going to go plant 1 trillion trees. And boom, here we go. We planting 1 trillion trees. And let me see, temperature goes down to 5.7. So more than Bill, but not quite as much as Alex was guessing. And it made a little bit of a dent. Let's see what really happened here. Here is the removals. Gigaton CO2 per year. How much is getting pulled out of the atmosphere? It gets up to about, what is this? Almost 8 gigatons. So think of that as, well, relative to what do we put into the atmosphere? We're put about 60 today. It's going to pull out 8. But the key is, in what decade does it pull out the 8 gigatons? That's 2080. It really gets going around 4 in the 2040s. The problem here is that you plant 1 trillion seedlings, and it takes a while for those trees to get big enough to remove a significant amount. Amy, you're adding, you meant to reseed. Okay, got it. Yeah, that makes more sense. So it takes a very long time. And you see here, overall greenhouse gas net emissions, right here, that only bends the curve out in the 2040s, when, of course, as you all know, to meet our goals, we need to be bending the curve back here in the 2020s. It takes a very long time, even if we were to plant a huge amount of land in these trees. The other challenge, of course, is, speaking of the huge amount of land, one should ask, who is living on this land? Who right now, this could challenge land use rights. Also, are they growing food on this land currently? What does that do to food prices? This is over 2.5 Indias of land. It is a large amount of land, challenging equity. So Libby says, is this interpretation global or US only? Libby, this is global. I am showing you a global model. That's how I'm able to calculate overall temperature. When you think of this, think of, well, with the land, it is much of this in South America, much in Asia. But when it comes to energy, I want you to think in that baseline that I was showing you before. This is about China, India, Mexico, Indonesia, South Africa, the places that are growing the fastest around the world, where overall energy demand is growing. Can we find out how many trees per year it is possible to plant, says Amy. There are some studies, and we found a study that really tried to look at this. I guess because it's a resource, I want to show it to you. So I'm back here on our website, and I want to look up a trillion trees, because I know we wrote some notes. The Washington Post covered some of our analysis of a trillion trees, and some of our analysis we documented in this blog post, which I'm going to give you. And I know there's a study in here about the land availability, and that study, I think, is way down here. Okay, there it is. Russell, see that? Do forests have the capacity for 1 trillion extra trees? So Russell et al., right, or just Russell alone, they handled it there. So I hope that is helpful. Max, can we share this link with folks? LinkedIn, yes, please. Please share it with anybody. Ideally, go in here, make your own scenario. Here's what I think we should do about climate change. And then click this, and then hit that button and share on LinkedIn yourself. And you would say, here's my vision. We don't talk enough in this field about what we'd like to see. I know. What was the first thing I asked you? I said, oh, let's go look at what we don't want to see. What do we don't want to see? We know what that is. It's all these things that I showed you before. We spend a lot of time looking at the worst case scenarios, like Charleston, South Carolina. Let's have you all go on LinkedIn and share your vision of what you'd really like to see. Okay, if that was one thing, if you have time, can we discuss the newest revenue and costs from taxes and subsidies graph? Wow, Greg's into it. You've looked at this before. So I'd like to look at that when we come around to show carbon pricing, because I know it will come up when I ask this next question. So send me back there, Greg. Okay, let's go. Instead of what are the things that get talked about too much, let's talk about what you'd really like to see and start constructing a scenario that you'd like. So please, let's add into chat, and I'm going to go back and make sure if I missed it earlier. How does the carbon price slide work? Right now it is 0. What is it all the way to the right? Thank you, Max. Okay. So please keep writing. Besides carbon pricing, what are the other things you'd like to explore? But I'm going to go straight there. I'm going to go straight there and correct a little something, Max. It looks like this is 0. This is not exactly 0. This is 5 because the world has a global carbon price averaged of $5 per ton CO2. 25% of the world's emissions currently has a carbon price, and it is around $20 a ton average. So we have put $5 a ton in there. If you want to go see where we got that number and see who has a carbon price and what those prices are, we like this database. You can go and just, again, send you there, and you can go and look and see all the different carbon prices, Canada's, Finland's, Argentina's, everybody's there. And someone asked, what is it on the right? On it is a fairly arbitrary number, which is $250 a ton. We don't tell you that is the maximum, or that is, we've here framed it as, well, that is very high. It is very high, because $250 a ton would be a very high carbon price. But you can make it even higher if you want, or lower. That's how you would want to test it. So what kind of carbon price, what would you like to test? And I'm going to ask you again to estimate what you think it would do if we did have such a carbon price. So folks, what would you like to try? Max, you prompted the carbon price. You can answer this, or anybody, if you write into chat, what carbon price would you like? Note, this would be global. And then, Greg, yes, I will come back and look at revenue and costs and tax and subsidies. $45, says Alex. 15 growing to 150, says Max. I might just take that. There it is. 250, says Alex. All right, we're going to go past 45, Alex. We're going to go through to 150. And then, Alex, we can shift it up to 250. All right. If we had $150 per ton carbon price, write into chat again. And, I need to go back and make this, we're going to make this Fahrenheit. Now, like I asked you with 1 trillion trees, 6 degrees F goes down where? We want to get below 3.6. If we go to 150, pardon?
Unbelievable.
Oh, yeah.
I think somebody is off of mute. Could you put mute back on? Unless, yeah, I don't think that was a question. So what do you think? Write into chat. What do you think the overall temperature will be in 2100 if we crank carbon price up to 150? And think of it in the United States, that would add $1.30 to a gallon of gas. It is a high, very high carbon price. So other folks who guessed before, make a guess. 4 degrees, 3 degrees F, 4 degrees F, 3 degrees F. We're trying to get to 3.6. Maybe it's kind of a one action that'll get us all the way there, all the way to 2. All right, let's go try it. Thank you for your guesses. I go under here, and someone says over 10 years. So this is, you can see how many years is it going to take us to get there. You can make it ramp slowly or quickly. I'm going to keep it at 10. And I'm going to put this up to 150, 150, and boom, there it is. Max, you were so close. Maybe you tested it. I wonder. I found that people open the model and do it themselves, but you're surprisingly accurate, Max. I have to admit, I'm a little suspicious, or I'm very, very proud of you. 4.5. Oh, Max, he admitted it. Yeah. Okay. All right. That was, I wonder if you change it to 4.4 so I wouldn't notice, but yeah. Okay, 4.5. It makes a huge dent. Look at what it does. Now, there's a key aspect I want you to do, not just the extent of temperature, but notice the timing. If it's implemented soon. Now, mind you, this gets implemented like next week, and it's more likely to say, no, this is a 2024, 2025, 2026 ramping up over time, and the longer we wait, the less it does, right? The longer we wait, the less it does. Don't forget that. But if it went in really soon, it would bring down emissions very soon. And I'm going to go look at coal. Here's coal. See coal dropping? Soon. Why? There is existing capacity of coal around the world, coal power generators. If there was a carbon price, we would use that existing capacity less. This is not the approach of just waiting for competition like wind, solar, nuclear fusion to drive out coal over time slowly. Instead, we use existing infrastructure less, so those emissions drop fast. Coming back to some impacts that you care about, if coal drops like that, think about air quality. What does air quality do? Does it bend the curve a little bit, maybe? What does it do? Does it bend the curve a little bit? No, it doesn't bend the curve a little bit. It brings it down fast. Look at how sudden we get those drops in air pollution. Look and imagine the health impacts of this around the world: cardiovascular disease, pulmonary problems, asthma, etc., from PM 2.5. It is a steep drop if we drop in coal. So it's not delayed. It affects the utilization of coal, oil, and gas. Oil a little bit less because it's not as carbon dense as the coal, and it's more difficult to shift transportation away from oil towards alternatives. Unless, of course, look what happens when we combine it with electrification of transport. Boy, that helps a good bit more. But I'm going to go back a step. Carbon pricing. Now, the challenge with this, and someone asked about revenue, the benefit, you could say, in the financial world, we now have revenue and costs from taxes and subsidies. So if we have a $150 a ton carbon price, that generates $3.6 trillion in revenue. Of course, people are going to fight over that trillion, 3.6 trillion. Saudi Aramco, Shell, Chevron will say it should come back to us. The governments would like to keep it to close deficits. Citizen climate lobby and others argue it should be dividended back to citizens. Like in Alaska, you get a check for oil revenue, every year. So there it is, and that's what to do with it. Max says, give it back to people and let them decide how to spend it. That's the third option that I just mentioned. Make it revenue neutral. Matt says, what specific emission scenario is this model using? Expected coal use projections seem high. I heard IPCC and most climate modelers are moving away from the highest scenarios like RCP 8.5. Okay, Matt, and just for everybody, I'm going to take a step into that world of how we compare in this world of all the other simulations. And Matt refers to a scenario called RCP 8.5, which 6 or 7 years ago, many were saying, hey, we could be on track for emissions going up very high to temperatures more like, well, in degrees C, more like 8 or 9 degrees F, like much, much higher. Yes, no one is considering, nobody, very few mainstream climate modelers are considering that to be a likely scenario or even worthy as a baseline. So let me talk about ours. What we've chosen is a baseline where we don't use other people's baselines and use other people's scenarios. Instead, we spend a lot of time comparing our scenario. And this is a deck I happen to have at the ready of many of our comparisons against others' models. And the best one we think to compare to is just the IPCC, the Intergovernmental Panel on Climate Change, where they take all the papers that are for what is the direction that implemented policies are headed. Now, when folks say implemented policies, often that means carbon prices increasing over time. Some people assume a strengthening of policies. What we've done is we said, no, we don't want to include any pledges in this. No one's saying we will meet a target by 2050 of this, or we will have carbon pricing going up over time. We've said, let's just take a conservative view and say, we don't assume those things are going to happen. You get to test them in the model. So when they say implemented policies, this is where greenhouse gas emissions would go. You can see this is different confidence bounds. It's a big range of the scientists out there, this overall orange range. And the baseline that you just saw would have us at the upper end of that range, and then at the upper end of this 25 to 75% percentile. So we're a little bit at the upper end of the range, and not assuming in particular that coal is going away unless you, when you sit down to play with it, make it go away. And what we find many people want to do is assume that coal actually could be on its way out. It could be having what they call structural decline, that the lack of profitability and government's desire to improve air quality, particularly, well, it's really it would be about China, like whether China has decided that they want to get rid of coal, because most of the new growth in coal is coming in China right now. But if you want to get rid of it, click here, and then you could say, you know what, I just don't see coal in the future. So I'm going to move this slider, reduce investment in new coal infrastructure. So if you want to say, we're just going to be no new coal infrastructure, you just say, this is where we're headed. And that means that this is what happens to coal, more like that. And then we have a temperature that's more like this. That would put us at the lower end. So that's how a little bit about how we think about this baseline. But I'm actually going to check and see if there are other questions that are coming up. So great to do this along the way. What temperature do we need by 2030 to save the world from climate change? Quote unquote, save. Okay, Alex. Temperature by 2030. Okay, I'm going to assume you're ready to see this, that some of the momentum in this system when it comes to 2030 temperature. Let's go look at it. And this is the reason why when you look at Charleston and you look at places dealing with climate change and the impacts of climate change, what we learn from playing with this model is that adaptation and preparation is necessary in all of these scenarios because of this. Watch. Well, I'll ask you to do it. We're going to make a scenario that is going to get down to 3.6. And then I'm going to look at temperature in 2030. This trend right here, and I want you to go look and you'll see temperature in 2030 to answer your question. So let's do it together, but I do want to come back of what temperature do we need to get to by 2030 to save ourselves from climate change. We're going to add back carbon pricing. What are the other things? So type it in there, and then we're going to come back to Alex's question. A little side note, Libby, what does register your event mean? Okay. Side note about all of this. What I'm doing right here, you could do yourself. We have an online course that you can go take. I shot 63 videos with my colleague, Ellie Johnston, and you can go and watch them and go. I'll go here to our website. If you go to the website, you can learn how to lead an event. An event is the En-ROADS Climate Workshop, which is exactly what I'm doing with you right now. And there's a video about it, and there's all sorts of training in it. What Bob mentioned at the start was the game that we have. It is a role-playing game that he and I led in a coffee shop in Greenville. It is an event. If you happen to be a teacher, there is homework. And you could give your students a homework, and then that would be an event. And if you lead an event, then you register it, means basically, hey, I'm here in Greenville, I ran an event, and I want to put it on the map. Here's the map that shows places around the world. Here, God, what did I just look at? Japan. Here are all the places in Japan where people have, I think that's Japan. Is that Japan? Tell me that's Japan. Where they have led an event. That's what we mean. But let's go back. What we're doing right now is in chat, you're suggesting all of the actions that are needed to get us to meet the goal. Then we're going to go back and answer Alex's question. Methane, says Bill. What else? I'm going to try to read these and make the changes. We stopped coal. We set carbon pricing of $150 a ton. By the way, I talk about registering events in the workshop. If you'd like us to come run an event for your community, we have people who could go out there. Some get paid. Sometimes like this, they just volunteer like I'm doing. You could do that. Are we double counting if we add carbon price and then add a separate tax on coal and oil? Good question, Max, because we are doing both here. No, you'll notice that you don't get that much more. So it's not double counting. It is only handling, each of them handles some part of this issue. So it's not double counting. What else? Oh, we said methane. Let's go look at methane. And one note about a really good graph to look at about what action in methane is needed is here. These are all the gases. These are all the gases that cause warming. And I'm going to go, if I go all the way back, let's see if this works. Here's where we started. 1, 2, no. Okay, here we were. Land use, carbon dioxide, burning coal, oil, and gas, F gases. There's the methane, nitrous oxide. This is all the gases. Below zero would be removals, like planting trees will pull us down. Okay. We're going to redo the actions we took. We said less coal, carbon price. You notice that dark area shrunk. That's fossil fuel CO2. Then Bill said methane. Watch methane in Carolina blue right there. Carolina blue, less methane. And it shrinks right there. Any consideration to green hydrogen? Alex, thank you. You know, we're adding it right now. I saw us including hydrogen as a way to get renewable energy to grow more, to deal with the intermittency problem of wind and solar. And we're adding it, and we're actually raising money right now. Can we add green hydrogen, blue hydrogen, pink hydrogen, yellow hydrogen? Those, we're trying to raise money right now to add those to the model. They're not in yet. Okay, coal, carbon price, methane. What else? What else to get down? And then I'm going to answer Katie. We'll come around to Katie's question. Here's the pollution. What else do we need to do? You could write in here. I want to see some more suggestions of what else we would need to do. Got methane, coal, carbon pricing. What else would we need to do before we go back to answer Alex's question about 2030 temperature? Carbon removal, Greg. Which kind of carbon removal? Regenerative ag, says Max. Okay, so here we are with, I'm going to go pull up carbon removal. Interesting, we have some bioenergy carbon capture and storage. The carbon price sparked just a little bit there. If we go under here, under direct air, we have direct air capture, enhanced mineralization, which is crushing up rocks that pull carbon out of the atmosphere. Ag soil carbon, that is the agriculture application. Here, watch as we boost that, and I'm going to see a lot of it. Here we go, and I'm going to redo it, and it is reducing overall land use CO2. So boom, we get a little bit of a benefit. Yes. What are the F gases for greenhouse gases? So hydrofluorocarbons, HFCs, SF6 is another, it's called an F gas. It was the air in Nike Air shoes until Nike reduced its carbon footprint, its carbon CO2e footprint, greenhouse gas footprint 75% by getting rid of this terrible greenhouse gas that they were putting in shoes. Animals are an important part of regenerative ag. Yes, let's go look at that. And it is a big source of deforestation. So we're going to go look at overall carbon emissions from land use. It's already dropped a little bit. Let's go look in here. Food from animals. If we have less food from animals, that decreases methane and deforestation emissions. Less food waste, reduction in deforestation like land protection. These are other things that bring it down. What are the other things that's needed? Well, some of the classics of electrification in transport, electric cars and energy, transportation systems, heat pumps, energy efficiency helps a good bit. Buildings and industry energy efficiency. All of these things could get us down below 3.6 degrees. As you're seeing, there's no one thing. We're not searching for the one thing. Even a carbon price isn't a silver bullet. It's not the one big thing that solves this problem. Actions are needed in many different areas to get us down below 3.6 degrees F. And you can see it is still possible to do it. Now, Alex, you asked earlier, what do we need to get temperature down to by 2030? We would love to bring temperature down in 2030. However, because of delays in the overall biogeochemical climate system, it takes a long time for the Earth's temperature to adjust to the new level of basically insulation that's around it, CO2 in the atmosphere, a long time, at least the order of decades. Therefore, when I go to temperature here, the difficult news is that when you look at 2030, Alex, here we are in 2023, temperature going up, it's going up a little bit more, 2.4, 2.5. Through 2030, we are likely not going to change the temperature rise over the next 7 years, no matter what we do with burning coal, oil, gas, methane, and deforestation, the big causes of climate change. So think of it as that we have locked into at least that kind of time frame. Now, mind you, we have not locked into the long term, but we have locked into at least several years of temperature rise. Therefore, we should be getting ready around the world. That said, in the long term, things do get a whole lot better. I'm going to pull up some of the things that we looked at the start. Look at these amazing results around biodiversity. Remember, I showed you mammals, 24% of species losing half their range. Now it's only 6 in this scenario. Invertebrates, 50% down to 11. The salamanders that live near here in Asheville. Here in Charleston, areas are green. A green area like this one, not at risk to sea level rise near Charleston. This is land saved by actions. It's not at risk to sea level rise. Other big benefits, of course, I showed you before, air pollution, so much better, and the health outcomes that come from this. So here are some of those benefits that we can see. I'm going to send you this scenario that we just made. I'm going to put it here into chat for you to go check it out. Bill is saying it, no silver bullet, instead silver buckshot, silver buckshot. And Alex, I'm glad you like that answer about 2030. 2030, 2030 adaptation and investments in resilience under all these scenarios. That's why preparing for what's coming needs to be hand in hand with all that we can do to bend these curves towards creating much better futures. So, a message of grounded hope, I hope, has landed with you. Much better futures are possible. We're not searching for the one big thing. It takes many actions across the board. It is still possible to bend that curve to stay below 3.6 F. And here is a tool. Go use it to engage others to think for themselves, because research shows that showing people research doesn't work. You can't just go tell them you're wrong, they're wrong, and you're right, and get in line, because that's not how we bring our communities and our world aboard of all the big solutions that are available to see all that can be done. All right. Can you find out which senators, Alex said? I'm going to go look at the chat. I'm sorry, I was missing it. You want to make sure I would say, Alex, yes, we'd love to get it to your senator. Send us a note and we'll tell you if we've been to them next. And Ruth, you're going to check on having a local presenter next spring. Fantastic. But Bob and Angela, maybe I'll shift it back over to you to wrap us up, because we're getting to the top of the hour.
Sure. Thank you, Drew. Definitely a fun and engaging webinar. I also want to thank everyone here today. I'll be emailing a recording of today's webinar later today. If you don't see it in your email box, make sure you check your junk mail. And I want to wish everybody a happy November. Bob, any last thoughts from you?
Just thank you very much, Drew. It's really great. It's very fun to see it in action, and just to be able to play with it and to see the result. And it's also really great to see you doing it with John Curtis, for example, and all those 30 House members sitting around in the look like the visitor center in the Capitol. Really great to have this tool available to decision makers and to the public. So yeah, like I say, we're real big on inroads. Now we got to talk about the branding, and whether we gonna we gotta it's we obviously weren't the only ones who noticed that EN stands for energy, entrepreneurship, the environment, things like that. So it's not patented, but very exciting to see what you do. And so thank you for doing it with us today. And thank you everybody for joining, and do spread it. As Drew said, it's available to be spread. Thanksgiving's coming. You can talk about it over the Thanksgiving table. Might be fun to do, So thanks everybody.